In this video, we're going to look at how to solve rational equations. So we're going to start with this one here. So typically a rational equation is one that involves rational expressions. Okay? A rational expression, though, is a fraction that has a variable in the denominator. So if you had something like, say, 1/2 here, and say x over 3 is plus 3/2 equal to 1, something like that. If it's just numerical fractions, usually we refer to those as fractional equations. So for a rational equation, we need to have at least one fraction with a variable in the denominator. Okay, so we'll start off with this one. So typically when we have a rational equation, we want to eliminate the fractions. Makes it easier to solve it. So we look at the denominators. Now if there's any denominators that you can factor, you go ahead and factor it. And then try to find the lowest common denominator, or the LCD. So in this case, we've got an x here, another denominator of x plus 1, and another one of 2. And they're all distinct there. So it makes sense a common denominator would be, or least common denominator would be, the product of these three factors. So in this case then, the LCD would be 2 times the x times the x plus 1. There it is. So we're just going to multiply through and then cancel factors that you could cancel. Okay? So look at we're going to multiply this times the 1 over x. So what's going to cancel out? You're going to get the x and the x are going to cancel. So you're going to have just 1 times x plus 1. In the second fraction, you have what? You have x plus 1 in common. So the x plus 1 and the x plus 1 will cancel. That'll leave you with 2x times the 3. Okay. In the next one, the only thing that's going to cancel is the 2. Okay. 2 will cancel. You have 3 times the x plus 1. And then here we don't, denominator is 1, so nothing cancels out. So we simply multiply by 1. 1 times 2x times x plus 1. Okay, so what do we have? So again, because the x canceled when we multiplied over here, we got left 2x plus 1. And then here for the second expression, the x plus 1 canceled, left with a minus 3. Okay, multiplying the 2, that'll give me the 6. And of course you got the x, minus 6x. The next one, the only thing canceled out is the 2. Okay, so that left me with 3x times the x plus 1. And on the right side, it's just 2x and x plus 1. So we multiply those out. So here we got 2x plus 2. And then for this product here, we got 3x squared plus 3x. And then on the right side, 2x times x is 2x squared. 2x times 1 is 2x plus 1. So what's going to happen here? Okay, now we need to collect our terms. Okay, a lot of times when you work these types of problems, when you multiply through by the LCD, you end up getting a quadratic equation. So generally you're going to solve a quadratic equation by factoring. If it doesn't factor, quadratic formula, method of completing the square. But factoring is usually the first method you want to try. So you can see here 2x squared and 3x squared. Those are going to cancel each other out, leaving me 1x squared there. Okay, the 2x and the 2x are going to cancel. Okay, and the 3x and the minus 6x will give me minus 3x. Okay, so 3x squared over gives me x squared. The 2x and the 2x cancel, and then the 3x and the minus 6x gives me 3x and the minus 6x is minus 3x. So what does that give me? Okay, we get x squared minus 3x plus 2 equals to 0. Quadratic, first thing you want to do is factor it. Okay, so let's get a factor into x minus 2, x minus 1. Okay, now you got a product of two factors equals 0. The only way that's going to happen is if one of the factors is 0 or they're both 0. So you set those equal to 0 and solve for x. Get x equal to 2, or x can equal to 1. Now just like with radical equations in the last video, you always want to check, okay? because what happens with radical equations, when you're solving, you usually isolate the radical and square both sides. Well, when you square both sides, that introduces a possibility that the equation will have extraneous solutions. That is, solutions that will work for the squared equation, but not for the original one. So you always want to check your answer. We have a similar thing with rational equations, okay? But if you do everything correct for a rational, when you're solving a rational equation, the only thing you want to make sure of that the answers you get, in this case 2 and 1, do not make the denominator 0, okay? In other words, if this x plus 1 were an x minus 2, say this x plus 1 was x minus 2, when you put a 2 where the x is, 2 minus 2 will give you a 0. So you would say this is not going to work. So you got to throw that one away. Or if this x plus 1, say, were x minus 1, then 1 minus 1 would give me 0. So that's not going to check. Okay? But if you do everything correct, your answer is going to check. Okay? Just to make sure, you can go ahead and check. That's your answer. X equal 2, x equal to 1. Look at the next one. Got 1 over x minus 1 plus 3 over x squared minus 1 is equal to x over x minus 1. Now, in this case, we have denominator of x minus 1, 1 of x squared minus 1, and 1 x minus 1, okay? So now in this case, we can factor this one. So this is going to be x minus 1 and x plus 1. Okay, so the LCD here then, it's going to have all the different factors are x minus 1. This one has x minus 1 and x plus 1, and this one has x minus 1. So the distinct factors are x minus 1. And x plus 1. Okay, that's going to be your general procedure for solving a rational equation. Factor each denominator if possible. In this case, only the second expression had a denominator that was factorable, x squared minus 1. And then from that you can figure out your LCD. So the LCD will contain factors of x minus 1 from this one, x minus 1 from this one. It's already there. You don't put it twice. Okay, and then this middle one here has x minus 1 and x plus 1. Okay, it's already got it. There it is. Okay, so now you're just going to multiply. This multiplies that one. Cancel out the like factors, then this one, and then this one. Okay, so for the first one, the x minus 1 and the x minus 1 will cancel, leaving me with x plus 1 over here. The middle one, x squared minus 1 is x minus 1, x plus 1, so that's going to cancel both of these with both of these. That's just going to leave me a 3. And this one, x minus 1 cancels, leaving me with x times x plus 1. Okay. So we do those calculations, okay, x minus 1, x plus 1 there. Then going through the multiplications, this is what we have left, okay. After we cancel, got x plus 1, this cancels out, leaves me a 3, and then here I get x times the x plus 1, and I just wrote it as x squared plus x. Okay, and then here the x and the x canceled, the 1 and the 3 is 4, so simplifies to x squared is equal to 4. Okay, you can factor that out, or you can see x squared is equal to 4, so 2 squared and minus 2 squared is 4. So the answer can be x equal to 2 or x equal to negative 2. And notice x equal to 2 doesn't make any denominator 0, so that should work. X minus 2 doesn't make any denominator 0, so that should work. Okay, you can go ahead and check it, but this is going to work. So this ends the video. Thanks for watching. We'll see you next time.